Welcome to Study Loop.
So in this problem, we have to find out the reaction equation for the standardization of sodium hydroxide solution by titrating with KHP, or the uh, potassium hydrogen pH phthalate, also known as KHP. And then we have to find the concentration of the sodium hydroxide solution at the equivalence point, as you're given the mass of the KHP required for the volume of sodium hydroxide. So let's first write the reaction equation here, where we have sodium hydroxide in aqueous condition will react with the KHP, and in the product we'll have sodium ion plus the potassium ion plus um, the C8H4O4 2 minus ion plus water. So this is the reaction equation for the standardization of sodium hydroxide with KHP. And the second part, we have to find the concentration of the sodium hydroxide, where we are given the mass of KHP, which is 0.5527 gram, and we have to find the concentration of sodium hydroxide at the equivalence point. For that, we need to know the number of moles of sodium hydroxide at equivalence point, and we have already given the volume of the sodium hydroxide. So first we have to find the number of moles of KHP using this mass, and as you know, at the equivalence point, the number of moles of the titrant at the titrated solution is equal. That means the number of moles of KHP at the equivalence point will be equal to the number of moles of sodium hydroxide, and using that we'll be able to find the concentration of sodium hydroxide. So to find the number of moles of KHP, first we have to know the molar mass of KHP. And which is 204.22 gram per mole. Now if we just divide the mass of KHP by the molar mass of KHP, we'll know the number of moles of KHP. So this value over this value will give us the number of moles, which is 0.0027. So this is the number of moles of KHP, and as we said that at the equivalence point, the number of moles of KHP will be equal to the number of moles of sodium hydroxide. That means this is the number of moles of sodium hydroxide at the equivalence point also. Now if we just divide this by the volume of the sodium hydroxide, we will get the concentration of the sodium hydroxide at the equivalence point. So the concentration of sodium hydroxide at equivalence point will be the number of moles we have just calculated, which is 0.0027 over the volume, which is 0.02587 liter, as we have given 25, as I've given the volume as 25.87 milliliter, so that will be 0.02587 liter, and the result will be 0.0146 molar. It's 1046, 0.1046 molar. So this is the concentration of the sodium hydroxide at the equivalence point.